In this video, I want to talk about how do you multiply matrices. Now, you might expect that, like adding and subtracting, that what you do is you take two matrices of the same size and then you just multiply the corresponding entries together. Now, it turns out you can do that. It is, however, just nowhere near as useful a multiplication as what I'm going to show you here. At some point in history, people come up with things, and those things are useful and they get used all the time, or they're not useful and they just sort of die out and no one even looks at them. This is one of those examples of they've tried all sorts of different ways of multiplying matrices to get it to be useful, and this is the one that really is the one that helps us out. Notice I have two matrices that are not the same size that I'm going to multiply together. However, although they're not the same size, there is something very nice about them. The first matrix that I have is 2 rows by 4 columns, right? So this is 2 by 4, if I can actually write with this pen. The second matrix is 4 by 3. In order for this multiplication that we're going to do to work, you need this to be the case, that the number of columns of the first matrix is equal to the number of rows of the second matrix. And then it'll turn out the result, if these two things are equal, the result here will be 2 by 3, the number of rows of the first by the number of columns of the second. So I've got a 2 by 4 times a 4 by 3. The answer will be 2 by 3. So here we go. I'm going to give myself a lot of room here. So I'm going to get the first row, the entry in the first row, first column. What I do is I take the first row here and the first column there, and I work my way across the row as I'm going down this one and multiplying corresponding entries, and then add them up. So I'm going to have 1 times 2. 1 times 2 is 2. And then add, dang nabbit, this is just ugly. And then add 2 times 0. And then add 3 times 1. And then add 4 times 3. Right? So I'm working my way across this row and down that column. The first entry in each one. The first entries get multiplied together, the second entries, the third entries, the fourth entries. There's the same number here as there are there, so that we don't run out of one too soon. So you do those multiplications and you add the results. Now, that was the first row, first column. Now let's look at the second row, first column. So I'm going to look at the second row of this and the first column of that. Right? So second row, first column is going to be 5 times 2 plus 6 times 0 plus 7 times 1 plus 8 times 3. 8 times 3 is 24, right? So there's the first row using the first column, the second row, and the first column. Now I can move over to doing the second column. I'm going to do the first row, second column, right? This would be the spot right here. So first row, second column. That would be -1 plus -1 plus 10 plus 21 plus 16. Well, that 21 looks a lot like a 4, doesn't it? I'm really looking forward to the new pen. Plus 16, and I'm going to be real disappointed if it doesn't work any better. So, second row, first column. Sorry, no, it's not. It's the first row, second column. So I'm using the first row and the second column. If I drop down here now, this would be the second row, second column. So let's use the second row here and the second column there. Getting -5 plus 30. -5 plus 30 plus 49 plus 32. And now I have one more column to go. I'm going to use the third column here. So first row, third column will give me my entry in the first row, third column. So I've got 0 plus 2 plus -6 right? Plus -4. And then we end with the second row, third column. So I use the second row and the third column, right? So 0 plus 6 plus -14 plus -8. And now we'll see if I can read my handwriting. So that product is equal to this. And I'm going to scoot a little bit smaller and say that is equal to, what do we got? 2 plus 3 plus 12. So that's 17. There's 9, 30, 44. Looks like 44. And I've got -4 minus another 4 is -8. And 17 and 24 is 41. And here, this is a big one. There's 60, 100, and 11 minus 5 is 106. And we've got -16. So this product of these two matrices is equal to this one. It was 2 by 4 times 4 by 3, right? Those are the sizes. The result is 2 by 3. 2 rows, 3 columns. Each entry, you figure out what entry are you in. This is the, looking at the 106 here. Second row, second column. So I use the second row and the second column and multiplying corresponding entries as I work across the row and down the column. Multiply them together, add those up. It seems really kind of complicated. However, there's a direct link to the solving systems of equations, because if you look at what we have on a system of equations, for instance, let's write a fairly simple system here, like 2x plus 3y, that's a 3, it looks like a 5, okay, so plus 5y equals 2x plus 5y equals 7, and 4x plus 3y equals 5. If you take a look at the right-hand side here, essentially what we have here is two equations. That's what we used to think of it as. But now we're going to say, wait, let's think of this instead as a single matrix equation. Let's think of this as a matrix on the left-hand side, which has two entries in it, 2x plus 5y and 4x plus 3y, right? And we're going to say that's equal to 7, 5. That this single matrix equation is equivalent to those two real number equations. Because in order for two matrices to be equal, you need corresponding entries equal. So you need this to equal that, and you need this to equal that. So it's the same thing. However, now look at what this is. I claim I can rewrite this like this. That 2x plus 5y, if I think of the 2 and the 5 coming from here, and the x and the y coming from here, and then I put the 4 and the 3 here, that the way you multiply matrices together is, notice this is a 2 by 2, 2 by 2, this is a 2 by 1, 2 by 1, so these two numbers are the same, the result is going to be 2 by 1, that's what this one is up here, and I get the entry in the first row, first column by using the first row and the first column, 2x plus 5y. I get the entry down here, which is the second row, first column, second row, first column, 4x plus 3y. So this system of equations up here can be rewritten as a single matrix equation that looks like this, right? This has just all the coefficients in it. This has the variables in it, and this has the constants that are over there on the other side. So we quite often will write something that looks like this. AX, now the book uses a boldface X. I don't have boldface here, so I'm just going to put a little hat on it, equals B. Here's what looks like a single equation, but it's a matrix equation. A is what's called the coefficient matrix. It's got a bunch of numbers in it. X has got all your variables in it, and B has got all these numbers over here. So where we used to have a whole system, a whole bunch of equations written down, now we have this bigger thing. Sorry, this simpler thing, which represents maybe something really big. This coefficient matrix in this example was 2 by 2, but if you have 5 equations and 7 variables, then A is going to be a 5 by 7 matrix. Okay? X is going to have 7 things, and it's going to have a column x1, x2, x3, all the way up to x7. B is going to have 7 things in it, b1, b2, b3, all the way down to b7. Right? This single matrix equation is going to allow us to express any system of linear equations in a very simple way. Okay? And the matrix multiplication is what helps, this definition of matrix multiplication is what helps us write this way. Okay? Anyway, you should definitely try a few matrices if you haven't already multiplied matrices together before. The section 1.3 has got a bunch of problems for you to just get some practice. Make sure you know how to do it. Once you know how to do it, then I'd say, let your calculator do it, because your calculator can do these things.